This is Kimon Onuma of Onuma Inc. in Pasadena, California, current chair of thought leadership at the Building Smart Alliance, a council of the National Institute of Building Sciences in Washington, D.C., and 2013 chair of technology and architectural practice at the AIA, the architecture of building informed environments. In 1983, Korean Airlines Flight 007 strayed into Soviet airspace due to a navigational problem and was shot down. That same year, in the height of the Cold War, President Reagan mandated through an executive order that the Department of Defense Global Positioning System, GPS, and satellite system be opened up for civilian use. For the greater good of safer navigation throughout the world, GPS was opened up and has had a huge impact on us today and how we navigate our world. When I visited the Trinity College Library and looked at the knowledge of a nation in analog format in books stacked 2 stories high, I imagined crossing the green ropes and climbing up a ladder to get to a piece of knowledge in a book. Data in analog format is no longer an efficient way to share information in our world today. Change and innovation are happening at a staggering rate. There was a Kodak moment in 2002 when digital cameras overtook analog cameras with the very technology that Kodak invented yet suppressed. Kodak lost focus on capturing and sharing memories with a business need to sell more paper and chemicals. Now, not only are we taking pictures, but we're locating them on a map through GPS. Location awareness has allowed us to find things on maps like Starbucks and has changed everything about how we navigate the world around us. Location awareness enabled by GPS is the foundation for the Internet of Things and smart cities, and access to real-time data such as finding the next bus, reserving a hotel, finding where our friends are, Googling everything. Data is stacked everywhere around us, and we expect this level of interactivity. It is no longer about one person trying to find one taxi on the street. It is a swarm of drivers networked through applications such as Uber that find you the right ride at the right place for the right price. This has fundamentally changed transportation in the city. Uber has overtaken taxis in 2015. They use the same global positioning system and other technologies combined together to bring you real-time access to rides. In this rapidly advancing world of smart cities and Internet of Things, we are all connected, but there's one gaping hole. The building industry has been overtaken by the technologies around us. As architects, we need to embrace the new tools and processes and change that's happening around us. When I look up, I see buildings, but I do not see the data yet. It's missing. We need to figure out how to make it front and center and connect to the world around us. Architects already process this complex data that can be incredibly valuable for this interconnected world. Even with building information modeling, though, it's very much a file-based and project-focused format. We finish the project, we file it, and the BIMs are used to process information just for that one use. But the capability exists because the information is there, it's just in the wrong format, even with BIM. The complexity of the building industry has required structure and order in the tools and processes that we use to capture the knowledge and decisions that we make. But let's not let the tools from the past limit what we can do with the data today. Knowledge trapped in an analog canyon of books or buildings is still valuable. We are in an incredibly unique position as architects, planners, and engineers that know how buildings and cities are put together to help structure and extract that data in a format that is valuable for others and link it to the technologies that are surrounding us. In this post-analog world, data and knowledge does not have to be stored and retrieved in a linear format. Cloud technologies and web services that drive Uber and other applications can be used to stream data from the cloud from BIM and support the Internet of Things in smart cities. BIM can link to it along with other information, but it's not necessarily at the center. Looking at bits of information as raindrops, one can then combine information to create new patterns, and machines can help crunch through those numbers to help us identify those patterns. So why this story about the disruptive force of global positioning systems? It is now time for disruption in the building industry to occur and take the building smart standards and align them with the technologies that have evolved around us. We were involved with a series of projects through the National Institute of Building Sciences for the Department of Defense, Defense Health Agency, and Department of Veterans Affairs for the facility data. They wanted to make their facility data more accessible to their internal teams and also their external consultants. The goal was to web service enable it and make it open and accessible. The DoD and VA jointly manage 210 million square foot portfolio, and the CEPS system is used to define the requirements for healthcare facilities and the equipment inside them. Very complex data, and this data was only accessible to internal users. Just like a defense satellite system can be opened for civilian use, certain parts of a facility data can be opened up as a service as well. That's what happened with CEPS. The knowledge base was structured in a way to be shared. White House directives for digital government using Silicon Valley strategies were used as the foundation for the CEPS strategic plan and defining the three-tiered architecture of moving the CEPS data into an open and accessible format and layering in a secure data service on top of it for apps to be built on top. Apps including the Space and Equipment Planning System, which was now called CEPS to BIM, and other BIM applications and non-BIM applications. The result is a level 3 in the cloud implementation of BIM tools. Data services to CEPS then were rapidly opened up. We did not require the CEPS development team to understand BIM or IFC or any of the standards. The first step was to take their data and web service enable it. Then other applications and vendors, within a few short months, started linking into the exact same data service with their tools, their BIM tools. So they were able to then translate CEPS data into their formats. 3D Warehouse took their equipment data objects and converted them into a 3D Warehouse format that then linked into SketchUp. A dental chair like this was made accessible with the same data. The Onuma system on the web used the same data as well. All the data coming from the same service align the different tools. The CEPS to BIM utility, you can go online and without any login actually, you can put in your information and call up a standard equipment and room type, and that can then be moved into other BIM applications as well. The simplicity of use was critical. Other applications like iPad applications then use the same data as well. This happened within a few short months after the data service was made accessible. BIM objects then took the same data and made it available in different formats, including IFC. In other words, what started as structured data in a non-IFC format now is available in IFC as well. Atenia, a non-BIM application with 40,000 pieces of equipment with attributes, about 200 attributes each, also linked to it very rapidly without even needing to understand anything about BIM. Their data then flows into other BIM applications as the connections are made. So if you open up another application that links to Atenia and links to the CEPS data, you can see the Atenia data actually pop up from the equipment list. So the end user doesn't have to be bothered with the complexity, but all of a sudden they have access to rich data that allows them to make decisions about the medical planning process. Revit, the same thing with APIs connected to the different web services, can see the same data and equipment. ArchiCAD then aligned their objects. The result is now multiple vendors all aligned with the owner's web service data for equipment and spaces. This Level 3 BIM implementation of owner data in the cloud is a huge first agile and lean step. It is an approach that can be expanded for any building type, not just for healthcare facilities or large owners. And it is not one system or one BIM or even one format like IFC. It is an ecosystem of data and systems and functionality that can be expanded over time, and it is ready to be used. This is an incredibly exciting time to be in the building industry. Transparency and collaboration are going to be key to move the industry forward, and we invite you all to join us. For those that are ready to change things, there's a way to start. BIM storms are going to be expanded to include all of what we talked about today. If you go to bimstorm.com/BIE, you will be able to sign up for an ongoing series of hands-on BIM storms and help us change the industry and build informed environments.